Our next topic is going to be looking at comparing slopes. So just in this top section, the try these, they give us a bunch of ratios to deal with. Just think of ratios as fractions. So this one here, we can actually rewrite it as 18 over 24. We can kind of imagine it like that. So when it says to write each of them in lowest terms, we can reduce them the same way we would with a fraction. So for 18 and 24, think of a number that divides into both of them. So for these ones, you can divide them both by 6. So if you were to do the same thing here, divide them both by 6, we could reduce this ratio to 3 to 4. And you can do the same thing for the next 3 here. So for 36 to 4, so I just say like this, I say this as 2, 36 to 4. We could reduce this by dividing both of them by 4. So 36 divided by 4 is 9, and 4 divided by 4 is 1. For this one, we could reduce it to 1 to 5. And then for the last one, you could reduce it to -5 to 2. So I just divided both of them by 2 there. So let's work through the next problem. It says these symbols below are used throughout North America. They warn skiers and snowboarders about the steepness and difficulty of ski runs. Pablo is a ski instructor in Lake Louise. So here are these symbols, and it talks about the grades under each of the symbols. So the green circle has a grade, and remember, grade is just the percent of the slope, or the percentage of the slope. So this, if we were to convert it back into a decimal, these would look like this. And when the grade gets bigger, that means that the slope of the hill is getting steeper and more dangerous. So Pablo laid a grid over a photo of the mountain. The new ski run has these coordinates. So this one here and this one there. What symbol should Pablo use to mark his ski run? So in order to determine which symbol he should use, we need to figure out the grade of the hill, or the slope of the hill. So remember our formula here. If we're given 2 coordinate points, we can use this formula, y2 minus y1 over x2 minus x1. So remember, whenever you're using this formula, I highly recommend labeling your coordinates x1, y1, and x2, y2. So here I'm just going to label this as x1, y1, and this one as x2, y2. Now what I'm going to do is I'm going to plug in the numbers into the formula. So you'll notice that y2 is 1,160, so that's why they put that here. And then in y1 we have 780. And then for x2 we have 1,140, and x1 we have 50. So 1,140 minus 50. So now let's actually calculate these. 1,160 minus 780 is equal to 380. And then for the bottom, 1,140 minus 50 is 1,090. So then if we were to figure out the decimal of this, because remember we need the decimal of the slope in order to figure out the percent from that. So we would do 380 divided by 1,090, and that would give us 0.348, and that decimal will keep going forever and ever and ever. So now let's figure out the grade from this slope. So we're going to take that and we're going to turn it into a percent. So by doing that, we are going to multiply by 100. So then you'll get 34.8% as the grade, or we can round it to 35%. So now if we're looking at these symbols, which symbol does 35% fall in? So this one goes from 6 to 25%, and this one here goes from 25 to 40%. So that's the one where 35 would land in between. So the mountain should be marked with the blue square. In the next example, we have Lydia is designing a house in Manitou. Each year, about 110 centimeters of snow falls in Manitou. Lydia has a plan with a roof pitch of 1 to 10 and another with a pitch of 2 to 3. which pitch would you suggest? So we're dealing with a situation here where there is a lot of snow falling, 110 centimeters, that is a lot. So when you have a lot of snowfall, you'll notice in Winnipeg, a lot of the roofs have steeper slopes on them so that the snow can run off of them and not gather. But if you go down south, let's say Florida, you'll see a lot of houses with flat roofs. And the reason they can have flat roofs is because they don't have snow there. So if snow were to sit on a flat roof, it would eventually start leaking into the house. That wouldn't be good for the house. So the steeper the slope of the roof when there's a lot of snow, the better. So let's figure out which one of these pitches would be more ideal for the roof. So remember, with these ratios, we can write them as fractions like this. So this would be our rise over run. And this one here again would be our, whoops, whoa, that was a weird 3. This one would be our rise and run again. So if we're using this little graph here, let's just graph them and see which one is a steeper slope. So we're going to start, I'm going to make a line segment anywhere on the graph. It doesn't matter where you start. So let's start the first one right here. So what I'm going to do is I'm going to rise up 1. So here, I'm going to do this one right here. So I'm going to rise up 1 and I'm going to run 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our next point is going to go right there. So then if you connect those 2 points, that there is the slope of that first line, or this roof pitch here. So now let's do the second pitch. We have 2 over 3. So I'm going to start that line anywhere on the graph. I'll do it right here. And now we are going to rise 2, so 1, 2, and run 3. 1, 2, 3. So that line is going to end right over here. So there are the 2 pitches of the roofs that Lydia is thinking of planning her house with. So now, which one would be better suited for an environment with a lot of snow? So it says here which pitch is steeper, because remember, we want the snow to slide off of it. If it sits on there, it's going to end up leaking into the house. So if we're talking about the pitch with the steeper slope, it would for sure be this one over here that is rise of 2 and run of 3. So I'm just going to put the 2 to 3 pitch is steeper. Now in part B, I just filled in that answer. It says, should Lydia use a flatter or a steeper pitch? And I said a steeper pitch so that the snow will fall off the roof and it doesn't pile up on it. And then finally in part C, it basically just says, which pitch would you suggest? And I would suggest the steeper one, which is 2 over 3, or 2 to 3. Either of those works. In example 2, it says Milo is a carpenter in Regina. For a project, he suggests staircases with a maximum grade of 80%. So that's the biggest the grade can go, or the highest. Compare these staircase designs. So here we have 3 staircase designs off to the side, and we need to complete this chart to figure out the grade of each of these staircases. So for each of them, we're going to be looking at the rise and run. So let's start off with staircase number 1. The rise for this one is 21 inches because that's the amount it's rising up, and the run is 38. So if we're figuring out the grade, we want to do the slope first. So rise over run, which is 21 over 38. And then we're going to divide both of those in our calculator, which is going to give us 0.552, and that'll keep going. And then the grade is the percentage of that decimal. So we're going to times it by 100, and that gives us 55%. So that's the grade of staircase number 1. For staircase number 2, we're going to do the exact same thing. We have our rise this time is 30, and our run is 19. So then we're going to do rise over run, so 30 over 19. And if we plug that into our calculator, you're going to get 1.578, and that'll keep going on forever. And let's turn that into a percent. So we are going to times it by 100%, and we should get 158%. That's the grade. That's a huge grade. And then for the last one here, we got our rise is 15 and our run is 38. So then we're going to do rise over run to find out the slope. So 15 divided by 38, that is 0.394, and then we need to convert that into a percentage. So let's times it by 100 and we will get 39%. So now let's order the staircases from least to greatest steepness. So least steepness will have the lowest grade. So we're going to start off, the lowest grade is staircase number 3. So I'm going to put number 3 here. Then the next highest steepness would be staircase number 1 with 55%. And then finally staircase number 2, which is 158%. So now it's asking which of these designs fit Milo's suggestion. So remember, the suggestion is staircases can have a maximum grade of 80%. So the biggest grade they should have is 80%. So the only ones that are under 80% would be staircases number 1 and 3, because both of those are under 80%. And that's because the grade is less than 80%. And then finally it says, how could you change the design that does not meet Milo's suggestion so that it does? So we're talking about staircase number 2 here. So if you look at the picture of staircase number 2, that if we're building a staircase like that, that is a really steep staircase. That would be a lot of high steps for you to take. So a suggestion would be to change the rise, to make the rise shorter. So I would say change the rise of staircase number 2 to 15 inches. So I just cut it in half, because then the staircase will be a lot easier for someone to climb.